Okay, hey Math Survey. We are looking at section 3.3 today. Take a few notes and then there'll be a textbook assignment today. So, linear equations with two variables. We're going to look at graphing a line in various methods. One is by using slope and the intercept. Another thing we're going to do is write the equation of a line, knowing a few things like slope and its y-intercept. And then also, what if we only know the slope and a point on that line? So those are the three things that we're going to cover. Should not take too long. All right, this you should be familiar with. This is called the slope-intercept form of a linear equation. And two things that we pick up off this, obviously you can see that the slope m would be this multiplier that sits in front of our x value, and many of you are aware of that. The other thing is the plus b, and we often refer to this b as the y-intercept. So that it gets its name, slope-intercept form of a linear equation. That y-intercept, if it's intercepting the y-axis, then its location is going to be x value of 0, and then whatever height that b turns out to be. So, but it always is going to be locating, with a 0 for x if it's going to land on our y-axis. Point slope form is often a very convenient form to use if I know the slope of a line and a point that it passes through. So here you can see we pick up our slope, that's where that belongs, and then we get the ordered pair. We have an x sub 1 and a y sub 1, giving us this point x1 comma y1, and this line would go through it. The other x and y that we see in the equation stay open, so that we, you know how we get y equals mx plus b. Well, this is a number and this is a number. What stays open for us is the y and the x, so that as I put in one x, I can get out a different y, or I can put in a y and get out an x. We have to have a couple of those open. So in this equation, the things that stay open as variables, is what I'm referring to as open, are going to be that x, y there. Okay, so let's walk through graphing a line. Graph a line using the slope and the y-intercept. Well, the first thing I notice is that this equation is in standard form, and they're asking for the slope and y-intercept. So let's solve this for y. Okay, so I'm just going to write solve for y, and start with my equation x plus 2y equals -4. Now, the first thing I want to do is keep in mind that it's the y value I want to get by itself. So I'm going to subtract x and move x away from that term with the y in it. And that brings me to 2y equals -x minus 4. And we're still driving forward, trying to get just one y, so I'm going to divide by 2. So both sides get divided by 2. It gives me y equals, I could rewrite this as a -1/2, negative coming from here, of course, negative, and it's over 2, so -1/2 x minus 4 over 2. So I'm just giving them each their own denominator of 2, right? Each of those terms get their denominator. And of course, this can be simplified. Y equals -1/2 x minus 2. This is what we refer to as slope-intercept form. And from that, we pick up two very key pieces of information. This, of course, is our slope, and this is my b, or my y-intercept. It's easy, isn't it, to graph off of this. I know my slope on this thing is a -1/2, and I know the y-intercept point is -2, so that's going to be a 0, -2 for my y-intercept. Well, the easiest place to start is to begin, right? B for begin. Begin at B. Our B value was 0, -2. That's the y-intercept. And then I need to move a slope. This tells me go down by 1, over to the right by 2. So I'm going to land here at 2, -3, it looks like. Down 1, right 2, and then we can connect with a line. Draw arrows on each end, and we have our linear equation. Next objective says to write an equation in standard form and in slope-intercept form. Okay, we can do that. And they give us the slope, and they say it's passing through the point 3, -4. So two things that I'm given. The slope, which I'm going to change to m here rather than writing the word slope. And then I go through a point that is 3, -4. Very convenient to start with this point slope form of the equation, right? That's what we're seeing here. So we're going to plug in our slope. And for the slope, I'm putting in 2/3. I have this x value has got to stay x, so it's a variable. And my y over here is going to stay y. We got minus and a minus on both spots. Now, y1, x1. y1, x sub 1, coming from our ordered pair that they gave us. So my x, or my y value was -4. So I replaced that with -4. And my x1 is 3. I think with a little bit of simplifying, I'm seeing this double negative on this side here, negative. So let's turn this into y plus 4 equals 2/3 x minus 3. This is a great point slope form. And I could graph off that, no problem. Plot the point, moved by the slope. But they ask us to write it in standard form and also in slope-intercept form. So let's move to, I'm tempted, let's go slope-intercept next, just because for slope-intercept, all we need to do is solve for y. So solve for y. Get a y equals equation. So let's go after this slope-intercept form first. So that'll be our step 1. To do that, I want to subtract 4. Okay, this will look a little bit messy. I'm going to subtract 4 from each side because we're going to have some fractions still existing here. I've got this 2/3 x minus 3 minus 4. Now that's not quite in the format that I'm thinking of. I bet it's not what you're thinking either. If I want slope-intercept form, I really want y equals mx plus b, just like we were working with on the previous page. If I want that form, then I need a number times x and then just another number at the end. I still see multiplication. So let's distribute through here. So we get y equals 2/3 x minus 3 times 2/3 minus 4. Oh, there's a little simplifying we can do here. 3 divides into 3 one time, doesn't it? So update our line, see what we got now. It should look a little bit better, shouldn't it? That turned out to be 2 minus 4. And one last rewrite, and we're going to be sitting in slope-intercept form. The -2 and the -4 come together to make -6. So this is slope-intercept form. The other form that it asks us to take things into is standard form. Standard form is kind of a fussy one, not my favorite, and it goes ax plus by equals c. This and this have to be integer numbers. So like -1, +1, +10, -10. That is the type of numbers, those are the type of numbers we're talking about. So I see that fraction then on my slope-intercept. This is going to be a problem for standard form, but we'll take care of it. Okay, first thing I notice about standard form, I have the x's and the y's on the same side, correct? So let's move our x over to the y side. So we're going to subtract 2/3 x from each side. That's going to give me -2/3 x plus y equals -6 remaining on the right side. Okay, remember me talking about integers? 2/3 is not an integer. So we want to make integers. Let's multiply by that 3. Just so we can get rid of the fraction. And you know what? The other thing, I'm going to multiply by -3 so that I can lead off with a positive number in that x position. So my x coefficient turns out to be positive, because that really is another requirement of standard form. Okay, so I'm going to distribute this all sides, or all terms. -3 times that will give me 6/3x plus, whoops, -3y equals positive 18. And of course, 6 divided by 3 is 2, so we get 2x minus 3y equals 18. This is standard form. Notice how my a value on ax plus b, a is a positive integer. And that is really a requirement for standard form. The other one just needs to be an integer. Doesn't have to be positive because we might not be able to force it to be positive. And this one also, just an integer. Okay? So if we'd had any more fractions left, we'd want to still multiply by something to get rid of the denominators, but we're sitting in good shape. Okay, those two are fussy forms and they will take a little bit of work. Here's a nice summary of different linear equations, the formats that we can see. We talked about slope-intercept form, we talked about point-slope, we talked about standard form. Okay. They do give you some shortcuts about slope. Slope could be calculated as -a over b. -a over b. Just pulling those coefficients from the x term and the y term, that gives us slope, which sometimes faster than taking this equation and converting it back there where we can pick up slope. So personal preference, if you want to solve for y, no problem. Also remember there's always these two special types of linear equations. The horizontal line, which doesn't look like y equals mx plus b exactly, does it? Except that horizontal lines have a slope of 0, so we get this y equals 0x plus b, and therefore that term is gone, and we just get y equals b. So there's our horizontal line. And then the other one's a little bit harder to explain. This is a vertical line, and we know vertical slopes, the slope does not exist, so all we get is x equals a here for our vertical lines. All right, that brings you to the work session, you guys. You can do your homework. It's multiple choice there, it looks like. Matching, match the equation with its graph. That may not be too bad. And then down here, write in slope-intercept form. Slope-intercept, so that's y equals mx plus b format. And give the slope of the line, okay, that's going to be our m equals. And then give the y-intercept, okay, that's our b equals, right? And then it says graph the line. So you're going to need some graph paper, and Miss Rink will have the graph paper for you. And then down here at the bottom, find an equation of a line that satisfies the given conditions. Write the equation in standard form, write it in slope-intercept form. So we have a point and a slope. I would take it into this format, you guys. The y minus y1 equals m, x minus x sub 1. That's what I would start with, okay? And you've got an example of that in your notes, so follow your notes. There you go. Hopefully you can get quite a bit done, and see you soon.